There's a little noise going on there. And it's pretty thick too. So a couple definitions we're going to start with. A function is increasing on an interval when its value increases from left to right. Just like you would read a book, you read from left to right. When you read a graph, you want to read a graph from left to right. A function is decreasing on an interval when its y value decreases, again, from left to right. So if I have this part of the graph here, okay, my graph looks something like this. It's pointed up, right? On the left-hand side, pointed up. So is it increasing or decreasing here? It's decreasing because it depends how you read it. If you read it from right to left, oh yes, it looks like it's increasing. But if you read it from left to right, then it's going to be dropping. So don't follow the arrows. Always read it from left to right. A function is constant on an interval when its y value remains the same. A relative minimum is a point where the function changes from decreasing to increasing. And a relative maximum is a point where the function changes from increasing to decreasing. Okay, so there are different kinds of maximums and minimums. Maximum means what in your mind? Like the most or the highest, right? And so if I had this graph here, right, you would think it has, up here is the maximum, right? Because it's the highest point of that graph. What would be the minimum point of this graph? It doesn't have a minimum, right? Because it keeps dropping. Well, if we look at increasing to decreasing, so here we're increasing, right? And then we decrease. And then we increase. And then we decrease. And how did I just define a relative maximum? What does it say? It's the point at where it changes from increase to decrease. So by that definition, how many maximums are there here? 2. So we got a maximum at that point and a maximum here, right? So relative maximum doesn't mean absolute maximum. There can be more than one, but it has to be the point where it changes from increase to decrease. If I have something like this, sorry, I didn't mean to put an arrow there. Okay, how many so these are supposed to be constant right here. The constant would be it's not increasing or decreasing, constant here. How many maximums, relative maximums, do you think are here? So it goes increasing, constant, decreasing, and there are no maximums here. No relative maximums, because it has to be a point where it changes from increase to decrease. Okay, so those are some things that we just need to be careful with when we're looking at graphs. So here's a graph. Answer the following questions about this piecewise defined function, f of x, shown below. State the open intervals, by the way, notation again. Open intervals versus a closed interval. So intervals are what we did with the domain and the range in the last unit, right? And an open interval Open signifies parentheses, where a closed interval would use brackets. Remember, brackets, you have that closed circle. Parentheses, we had the open circle when we were graphing. And so that terminology carries over with open interval or closed interval. When we talk about open interval or closed interval, we're talking about x values only, okay, or part of the domain. So this is really saying, state what part of the domain of this function is increasing. Okay? So what would you say? So it's increasing from negative infinity all the way until it gets to, okay, so I'll trace that for us. So increasing here. So that open interval would be negative infinity to -1. Do I put a bracket with the -1 or a parenthesis? Parenthesis, why? Because it says open interval, so we're not using brackets at all. Okay. Yes, it is a closed circle there, but when it says open interval, that's saying only use parentheses. Okay. Is it increasing anywhere else? Okay. All right, and remember we use the union symbol to connect intervals. So we're only using x values. The 7 came from the x-axis, so did the 1 here, so the -1 and the negative infinity. Part B, state the open intervals on which f is decreasing. What would that be? -1 to 1. And then state the domain and range of f. That's something we did in the last unit. So when you're stating the domain and range, you do it like we did it before. So you got to think, should it be brackets or should it be parentheses? Is there a break in the graph? So go ahead and state part C like we would with the last unit. And for a domain, Trenton, what'd you get? Okay. And then in terms of parentheses or brackets, what'd you do? Good. Because we have that closed circle at the 7, we want to include it. Use the bracket. Good. And for the range, Isaiah, what'd you get? Didn't get it? Okay. Megan, did you get it? Okay, so now we're looking at the lowest point. So range is really the only time you grab the y values. So negative infinity, and then the highest value is at height 4, and it happens at 2 spots, and it is closed at both those spots. So we grab that. Okay, good. So D, state the coordinates of any relative minimums of f, and E, state the coordinates of any relative maximums of f. Go ahead and do that, and pay attention again to the definition of a relative min and a relative max as you do that. So for relative minimums, Ryan, what'd you put? 1, 2. Okay, any others, or is that the only one you put? Only one, okay. And 1, 2 is the only one, because again, a relative minimum is where it changes from decreasing, I'll put DEC, to increasing. And that's the only place that happens. It isn't the lowest point, so it's not the absolute minimum, but it is a minimum relative to that area. So that's why we say relative minimum. Careful with notation now. If you look at B and you look at B, on the surface they look like they're representing the same thing, but if you look into the context, they represent very different things. So D represents 1 point with an x and y coordinate, right? Where B would represent an infinite number of numbers between -1 and 1, and they're only x values. So please pay attention to notation and understand the context behind this, because the notation could look the same, but the context would mean something different. E, state the coordinates of any relative maximums. Laura, what'd you put? -1, 4. And if we look at that, it's changing from increasing to decreasing. And so definitely that's a relative maximum. Any others? The question is, what about that endpoint? Do we think that's a relative maximum or not? Saying no, why not? Doesn't follow the definition. It goes from increasing to, we don't know. It could keep increasing. It could be constant. It could be decreasing, or just stop. And if so, endpoints are never minimums, never maximums. And so -1, 4 is the only one. All right, so now where we left off from last unit, writing a piecewise defined function and what you're working on with the project that accurately represents the graph of the function below. So when you do this, using function notation, you're going to use the curly bracket, just the open. You're not going to close it. You're going to write your two equations here, and then you're going to put the restriction. So you're going to put the word for, and then the domain restriction. And so I want you, again, just go ahead and do that. We have some experience with this. So find out the equation of both those pieces, put them on, and state the restrictions and domains. Remember, the domains here are not in interval notation. We're going to use inequality notation for those restrictions. So we have two pieces here. We have our parabola as our first piece, and a segment of a line for the second piece. And for the equation of the parabola, we're going to start with the parent graph, but it's been moved to the left one, up 1, 2, 3 units. Actually, sorry, up 4 units from 0, 0, because that's where our vertex is. And so we know it's going to be in the form y equals a times x, moving left 1, so we put +1 squared, up 4. So it's in that form, but we need to figure out what a is. So we pick another point that our equation goes through. The vertex won't help us in this one. And so maybe pick 1, 2, our relative minimum, and plug 1 in for x, 2 in for y. See what we end up with. So I'm going to subtract 4. Raise to negative infinity. Then divide both sides by 4. So you get -2 over 4 is equal to a, and you can reduce that to -1/2. And we know it has to be negative because the parabola is opening down, and that's what that that value of a does to that. So negative 1/2 x plus 1 squared plus 4. You don't want to put the y equals in here because we already have that. That's what the f of x equals signifies. That's your y equals. So you're just putting what comes after the y equals in for that part. And then you want to state the restriction or the domain restriction for that. And it's from negative infinity less than x. And we get to choose. Should it be an open circle or a closed circle there? What'd you guys do? I hear both. I heard open first, so I'll do open. So I'm going to make it an open circle. But if I make it an open circle for this one, I have to make it a closed circle for the other. So as long as you make it open for one and closed for the other, it's fine. You can't make it open for both. You can't make it closed for both. So open up to 1. The next one is a line, and I'm going to use this minimum point here. We've been moved to the right one up to. We have some slope here. Okay. And then check your slope by counting rise over run. So we're going up 2 over 1, 2, 3, 4, 5, 6. Or 1/3. So we get 1/3 x minus 1 plus 2. And that's between 1 and 7. And I'm going to make both of those closed. And that would be an acceptable equation. Okay. Any questions on what you have? Because some of these things can look different. The parabola equation has to be exactly the same. But you could have an equal sign here with the 1. And you would have to take it off here. Also, the line equation could be different depending on which point you took. You'd have to have the same slope, but this second part can vary. No questions? All right, so you're going to try that on this next one. A through G. Same kinds of questions, just another example. All right, so let's go over this on A. Abigail, what'd you get? Okay, 0, 2. And did you use brackets, parentheses, parentheses? And you're using parentheses because it says open, exactly. Okay, so 0 to 2, we do see it's increasing. Right there. Okay, good. B, Megan, what'd you get? Okay, so -4 to 0, these are x values only, and we're talking decreasing right here and right here. And then C, state the open intervals or interval on which f is constant. Luis? Or 6. Brackets or parentheses? Only parentheses, because all these are saying open intervals, right? Okay. Then D, we have the domain and the range. I'm going to split that up. So first, let's look at the domain. Domain, Andrea, what did you get? Perfect, thank you. And then for the range, what did you get, Shelby? And then brackets for the 1, or? Yeah, okay, good. So range, we're looking at the height here at 1 and down 1, 2, 3, 4. Count 5. Did I do that wrong? 1, 2. Oh, you gotta go a little further. Yeah, good. Right over here. That's the lowest part. E, state the coordinates of any relative minimums of F. Cole? Any others? Okay, so let's take a look at those. So 0, -5, it's right here, and 4, -6, right here. So on this point right here, it changes between what and what? Cool. Decreasing to increasing. Okay. And by definition, if you have that change, it's a relative minimum. This one changes between what and what? Well, it's not nothing. We call it constant. Decreasing to constant. And so when you have that, we can't say it's a relative minimum. Okay. But we're learning that, and so it's good to discuss that. So F, state the coordinates of any relative maximums of F. King Bao? 2, -2. Good. Any others? Okay. And you're right. It's because it changes from increasing to decreasing. The only other tempting one is the endpoint, but endpoints we can't label as maximum. Okay. Then we have a piecewise function, and you have to decide how to split these pieces up. Now, got a constant one there. Okay. Can I do this? Can I have this be the absolute value, and this one just be another line? Why not? Okay, so you gotta pay attention to slope here. It is a V shape, but the slope on the right hand side or on the left hand side is going to be up 1, 2, 3 over 2. So you have, let me just write the slopes here. So this slope is positive 3 over 2. The slope on the right one, if it were a true V shape, or would go with absolute value, would have to be what? Have to be the same, but negative, right? It'd be negative 3 over 2. And here we have a negative 1, 2, 3, 4 over 2. So negative 4 over 2, which is negative 2. And so, yeah, definitely not matching up. So just wanted to point that out. We can't break it up that way. So how about this one? Can we use that V shape? So we check this slope. And we have up 1, 2, 3, 4, 5, 6 over 4. So 6 over 4, which reduces to 3 over 2, and should be negative. So we have a negative 3 over 2 and a positive 3 over 2, so definitely we can use that one. Okay. And so here, the first thing we're doing is just identifying what should our three pieces be, and there we have them. And so we're going to now put our equations in. So f of x, and when you write this, we're going left to right. Okay, so our three equations for a certain restricted domain. So for the first equation, May, did you get the first equation? What'd you get? Perfect. Okay. So it's 3 over 2 because that's the slope of the right-hand side. Absolute value of x because we're not moving left or right from the y-axis. We're staying at value of 0 for x. But we are dropping down 5 units. And so, very good. And Isaiah, what would be the restriction for that? Yeah, this part right here, yeah. The -4 less than or equal or less than to x, and then you set up to 2. Now here we have a choice. We could do less than or less than or equal. I'll do less than 2, okay? Because it's shared between the blue and the yellow there. All right, so the next one we have a line, and we need the equation of that line. Danielle, did you get the equation of that, the yellow one? What'd you get? Negative, so let me write that. So -3 x, what'd you say next? -2, and then -2 again? Okay, so let's just check. So you're using the first point, and you see that it shifted right 2 and down 2, and that's what this does, shifts it right 2, down 2. And then our slope, I got a -2, you got a -3. I'll double check, because sometimes I make an error. Down 1, 2, 3, 4, right 2. I'm -2. Okay, so just change that to -2. Everything else is good. Okay, and that's for a restricted domain. Basing off what I did at first, how do we continue this, Allison? What would I put for the restriction for that line? Good. All right, and then the last line is not too bad, right? Kylie, what would the equation of that one be? -6. Because it's just constant there, right? And then from where to where, Stacy? 4 to 6. And should I put less than signs or less than or equal signs? Perfect. That's what we want. Okay. So really, there wasn't much new here. There was some new terms, right? And so homework is to finish worksheet 1, and I'll let you guys do that.